Okay. So, we now move to types of function. There are various types of functions. We will be taking one by one. First, let us understand what is a linear function. A linear function are those functions whose graph is a straight line. I told you while defining function that every function can be graphically represented. Okay. How? Function is actually an expression given in terms of variable. So, normally it will have two variables or more than two variables, where we will have independent variables as well as dependent variables. Independent variables are those variables whose values we can assume and take the values, whereas dependent variable is that variable which have to be calculated by the assumed values. So, whatever values we assume for the independent variable, we have to put those values and do the calculation, and therefore, we can find out the value of the other. As a result, that variable is called a dependent variable. Okay. So, every function can be represented in the graph. So, it will follow a pattern. Once we find the values of x and y and we plot the points in the x coordinate and y coordinate, and then we can draw a curve joining all this particular line, giving an idea that what is the shape of this curve. Now, when we talk about linear functions, every time you will get a straight line. Whatever points you find from the given relation, and you put it in the graph paper, you plot those points in x coordinate against x axis and y axis, and then if you try to join, you will always get a straight line. So, that is a property of linear function. Linear functions are those functions whose graph is a straight line. Okay. All linear functions are of the form y is equal to a plus bx. Y can also be symbolically represented as f of x. So, either we write y is equal to a plus bx, or we write f of x is equal to a plus bx. That is the form of a linear function, where a and b are constants. They are any real numbers. Okay. A and b are constants, and uh, a, this will be small letter a, not capital. A is the y intercept and b is known as the slope. So, first of all, the generic form of a linear equation is y is equal to a plus bx, where y gives us the y intercept. That means, if a straight line is drawn, okay, then at what point is the straight line cutting the y axis, and what is the length from the origin to that particular point? That is called the intercept. Intercept is basically the portion of a straight line intersected by two other straight lines. So, now you know that in a graph paper we have got two perpendicular straight lines. Okay. One is called the x axis and the other is called the y axis. If I draw another straight line with the help of the plots, with the help of the points, then that straight line either can be parallel to x axis or parallel to y axis, or that straight line can be an intersecting straight line. It might intersect the x axis at a point as well as the y axis at a point. So, the length of the y axis starting from the origin to the point of intersection is what is called the y intercept, and that y intercept is given by the value a. So, a is the y intercept and b is known as the slope of the line. Now, slope of the line, probably if you have done coordinate geometry earlier, you know already that slope of a line is nothing but the tangent of the angle made by a given straight line with the positive direction of x axis. So, if we know the angle made by a straight line with the positive direction of x axis, then we find out the tangent of that, tan theta, then that is the value of the slope, and that slope will automatically be the same value as that of b. So, if we have our linear polynomial in the form of y is equal to a plus bx, y will be the y intercept from the graph once we plot this in the graph paper, and b will be the slope of the line. Okay. So, here is an example. Suppose you have y is equal to 3 plus 2x. So, here x is the independent variable and y is the dependent variable. Why is that so? Because x's values we can take at our own will. I can put x equal to 0, I can put x equal to plus 1 or x equal to minus 1, plus 2, minus 2, anything. and accordingly I can calculate this value, and thereby I will get the values of y. That is why y is called the dependent variable and x is called the independent variable. Now, say for example, if I take x is equal to 0, then the value of y will be 3, as because we will get 3 plus 2 into 0, which is 3. If I take x is equal to 1, then the value of y will be 5. 3 plus 2 into 1 is 5. If I take x is equal to minus 1, then the value of y will be 1. Why? Because we will get 3 plus 2 into minus 1, which is minus 2. So, ultimately y will be 3 minus 2, which will be 1. So, this way, by taking various values of x, we can find out the values of y, and then when we plot all these points in a graph paper and try to join them, we will definitely get a straight line. So, that is an example of a linear polynomial. You can try it out, you can make a box and write down x and y, and for various values of x, you can calculate and find out what are the values of y. Go to your graph paper, okay, and then plot points that against x is equal to 0 and y is equal to 3, where will be your dot? I believe you know how to plot points on a graph paper. So, if it is x equal to 0 and y is equal to 3, so the point will be on the y axis. Okay. Starting from 0, we move towards the upper part or towards the top of the y axis, 1, 2, 3, and we will give a point there. Coming to next, if we have x is equal to 1, then y is equal to 5. So, we go to the x axis, find out where is x equal to 1, and then start going up, 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 stop at y equal to 5, and we put a point there. So, that way we can actually plot points corresponding to the various values of x and y. Once you plot all those 3, 4, 5 points, and then you take your scale and try, you will find that they all are in a straight line. Okay. So, that is an example of linear polynomial function, okay, or a linear function, where we have two variables. One is an independent variable and the other is a dependent variable. Let us come to the next function. So, we understood linear function. Now, if anybody tells you linear function, the first thing you need to understand is there are two variables in that expression. One is an independent variable, the other is a dependent variable. Second, if we represent it in the graph paper, then it will always be a straight line. Okay. Now, the generic form of a linear equation is written in the form of y is equal to a plus bx, where x is the independent variable, y is the dependent variable, a is the y-intercept and b is the slope. Okay. And here are the examples. You can have y is equal to 3 plus 2x, or only y equal to 2x is also a linear function. We next move to the second type of function, and that is a quadratic function. The name quadratic indicates that the dependent variable's power is 2. Okay, that is how the name comes, quadratic. Linear means the dependent variable's maximum power is 1. So, here we have x to the power 1, only x means x to the power 1. But for quadratic functions, the maximum power of the dependent variable will be 2, and hence the name quadratic. So, a function of the form y is equal to ax square plus bx plus c. So, it is a trinomial, it has got 3 terms. So, y is equal to ax square plus bx plus c. If a function is of this form, where your a, b and c are real numbers, and a is not equal to 0, very, very important, a is not equal to 0, like unlike here, there of course, your b cannot be equal to 0. If b becomes equal to 0, then it will not remain a linear polynomial. X will be removed if b becomes equal to 0. Similarly, if a becomes equal to 0, x square will no more exist, and therefore, this function will become a linear function. It will not remain a quadratic function. Therefore, it is a very important condition that a, b and c are constants or real numbers, and a is not equal to 0, a cannot be equal to 0. Graph of a quadratic function is not a straight line, please remember. It is a curve which is called parabola. If you plot all the points in the graph and you need to join by freehand, because we cannot join by scale. The previous case, you could have taken a ruler and drawn the line, as because it is a straight line. But in this case, if you plot all the points, either it will be in the shape of a U, or an inverted U, or it can also be a U opening towards the left or towards the right. Such a shape of a curve is called, it's a bell-shaped curve which is open either at the top or at the bottom. Such a shape is called a parabola. So, quadratic functions represents the shape called parabola graphically when we plot them in the graph paper. I repeat again, when we say quadratic functions, the first thing that should come to our mind is that it is an expression where we have dependent and independent variables, but the highest power of the dependent variable will be 2. So, thereby the generic form of representing a quadratic function is y is equal to ax square plus bx plus c, where a, b and c are constants or real numbers. But please remember, a cannot be equal to 0. Okay? And the graph when plotted, we can again find out, we can take various values of x, like we can take x is equal to 0, x equal to 1, x equal to 2 or minus 1, minus 2, and accordingly we will get different values of y. So, similarly we can go to the graph paper and we can plot the points for x against y, and when we try to join them with the help of freehand, so we get a curve, okay, which is in the form of a bell shape, which may be either open towards the top or towards the bottom or left or right. Such a shape is called the parabola. So, quadratic functions normally represents the shape of parabola in the graph, and linear functions represents the shape of a straight line in the graph. Next is your polynomial function. Polynomial function. Now, what is a polynomial? A polynomial is an algebraic expression. If you have done algebraic expression, we all did in the school. So, an algebraic expression which have only positive integral powers of the variable is called a polynomial. So, a polynomial cannot have negative powers and a polynomial cannot have fractional powers. Fractional powers like square root or cube root, those are actually fractional powers, 1 by 2, 1 by 3 and so on and so forth. So, if we are talking about a polynomial, then it should be an expression, an algebraic expression, which should have only positive integral powers of the dependent variable. So, polynomial function, these are the functions that contain expressions including only positive exponents of the independent variable, sorry, not dependent, independent variable. So, functions which contain expressions including only positive exponents, exponents means the powers. So, expressions that includes only positive exponents of the independent variable is what is called a polynomial function. So, if I take you to the previous slide and I ask you y is equal to ax square plus bx plus c, is this a polynomial function? The answer is yes, because the powers are positive integral values. X's power is 2 here, x's power is 1 here and x's power is 0 here. No x means x to the power 0. So, the powers of the independent variables has got positive integral values and therefore, it is a polynomial function. Even your linear function is also a polynomial function is because the power or the exponents of x is 1. Okay. So, the general form of a polynomial function is defined as follows. Generic term or the generic representation of a polynomial function is represented as Px. Okay. Px represents the function in terms of x, and then we can have a n x to the power n plus a n minus 1 x to the power n minus 1 plus a n minus 2 x to the power n minus 2 and dot dot dot. So, it can continue, and then we can have a 2 x to the power 2 plus a 1 x to the power 1 and plus a naught. A 0 is actually called a naught and it will be x to the power 0. X to the power 0 is 1. We know that anything to the power 0 is 1. So, that is why it is not written as x to the power 0. But this will be the last step. It cannot go beyond this, because if it tries to go beyond this, then the power of x should be negative. And as per the definition of polynomial function, the exponents will only be positive integers. It cannot take negative values. So, it starts from any positive power and it can continue till it reaches the constant term, which has got x to the power 0 as the power. So, this is the generic form of representing a polynomial function. Px is equal to a n x to the power n plus a n minus 1 x to the power n minus 1 plus a n minus 2 x to the power n minus 2 and plus dot dot dot. This continues. So, we get a 2 x square plus a 1 x plus a naught. Okay. That is the generic representation of a polynomial function. Next, so in polynomial function, you get a term which is called degree of the polynomial function. So, what is this degree of the polynomial function? Let us understand. The degree of a polynomial function is the highest power of the variable in the function, highest power of the independent variable in the function. So, if you have a polynomial function and if you are asked to find out the degree of the polynomial function, we actually have to check and find out what is the highest power of the independent variable given in that particular function, and that highest power is called the degree of the polynomial. So, in this case, if you ask me what is the degree of this polynomial, the answer is n. Why n? Because n is the highest power of the independent variable x. So, the degree of this polynomial is n. If we go to our previous slide, suppose if I ask you what is the degree of this polynomial, y is equal to ax square plus bx plus c. What is the degree of this polynomial? The answer is 2. 2 is the highest power of the independent variable x. What is the degree of this polynomial? Y is equal to 3 plus 2x. The answer is 1, because 1 is the highest power of the independent variable. So, whenever we ask about degree of a polynomial, it means the highest power of the variable present in the function. Okay. So, that is the degree of a polynomial. I hope now the polynomial functions are clear. The general form of representing a polynomial function is also clear to you. And finally, the degree of the polynomial function.